In our work as doulas, we're often working with clients later in their pregnancies, long after most of the fetal development has occurred. It's important, however, for us as doulas to understand the stages of fetal development, to have an idea of what it was like for the woman as her baby was growing inside. Our clients will refer to their unborn child as their baby, not as a fetus or an embryo. So in this session, I'll show you the stage of development that's referred to as the embryo and that which is referred to as the fetus. But most often, I'm going to use the word baby, just like our clients do. Here we see a picture of a baby at about 1 year of age. You can see that this baby is able to sit up by himself. He can probably crawl away quite easily, and most likely can pull himself up to a standing position and maybe even toddle about. But would you consider this a 1-year-old child? This baby who may not be able to roll over by herself yet? Could maybe grasp at but not actually reach and touch an object near her, and can barely hold her head up. Yet this baby has been around for a full year. She was born 3 months ago, but spent 9 months inside her mother's body and experiencing a lot of different things. Let's take a look at her. This illustration shows the first 11 days of human development. As we can see in the lower center part of the illustration, the ovary has just released an egg. The fimbriae, or finger-like projections of the fallopian tube, draw that egg into the arm of the fallopian tube. And around day 1, fertilization occurs in that outer part. We can see that sperm have reached this egg, fertilization has occurred, and then cell division begins. About every 12 to 24 hours, another cell division will occur. Each of the cells divides until a clump of cells, like a blackberry, is formed. At this point, any one of those cells could be withdrawn and start a whole new baby. Each cell contains the exact identical information chromosomally so that this can become a full person. The first type of cell differentiation occurs when the blastocyst is formed. As we can see in the illustration of the blastocyst, some of the cells have clumped together to form the inner cell mass. That's going to become the baby. The other cells form a single layer around a sphere. Those are going to become the placenta. When the blastocyst drops into the body of the uterus, wherever it lands is where implantation will occur and the placenta will grow. So we see the blastocyst starting to burrow into the wall, and eventually it burrows all the way in. And we see another type of cell differentiation occurring in the bottom illustration, where the cells are forming a flattened disc. We'll learn more about that in a moment. Here's an actual photograph of an egg and a sperm. As you can see, the ovum is the largest cell in the human body, and the sperm is one of the smallest. Here we see a photograph of the first cell division. That bluish sphere that surrounds the two cells is the zona pellucida, a thin membrane that holds the developing cells in place. This photograph shows another blastocyst. We see the inner cell mass in the lower right-hand corner and the thin layer of cells, the trophectoderm, around the outside. And in these photographs, we see the inner cell mass and trophectoderm inside the zona pellucida, and then in the right-hand illustration, the cells have broken free of the zona pellucida, which they need to do before implantation occurs. Here's the types of cell differentiation I was referring to earlier. By the end of the first week, 2 tissue types are created in that flattened disc. The ectoderm, which will form the outer part of the baby's body, its skin, sensory organs, brain, and nervous system, and the endoderm, which forms the internal organs such as the gut, lungs, liver, and glands. By the end of the second week, the third type of cell division occurs, and that's the mesoderm, the middle layer, which forms the bones, muscles, connective tissues, circulatory system, and smooth muscles of the digestive tract. In the third week after fertilization, neurogenesis, or creation of nerve cells, occurs at a rate of over 250,000 cells per minute. Each neuron has up to 15,000 synapses, and they're being created at a rate of 1.8 million per second between 8 weeks gestation and 2 years after birth. No wonder pregnant women are so tired. By 9 weeks, the spinal cord is formed and starting to function. Here we see a photograph of an embryo at 5 weeks from conception. The first 8 weeks of development, the baby is called an embryo. We can see in this photograph the baby's brain beginning to form and the eye socket. The way that a baby's eye forms is first the socket is created, then the eye sphere begins to develop, then lids form over that while the internal structures of the eyeball form. And when the internal structures are developed, then the eyelids will open again and the baby will start to develop its visual capacities even before it's born. In the center of this photograph, we see the dark area, which is the heart. The heart is the first organ to start functioning. And usually around 8 weeks, its beating can be visualized by ultrasound. We also see the liver forming and small arm and leg buns. The umbilical cord is starting to form, as is the placenta, but at this point the baby is getting most of its nutrients still from the yolk sac. Here we see a 6-week-old embryo in its sac. This baby unfortunately hasn't survived, but seeing this photograph allows us to see the size difference between the unborn baby and the adult fingers. So you can see just how small that 6-week-old embryo was. And what do you think that dark area in the center is? That's the baby's heart. Here we see a 6-week-old embryo. And look the difference from the 5-week-old embryo where we see the beginning of that eyeball forming. We see how much development has occurred in the arm and leg buds. The umbilical cord and placenta are continuing to develop and will continue until they're fully functional at about 12 weeks. 2 weeks later, look at how much growth has occurred. Now we can see the 2 hemispheres of the brain forming. You can see much more development of the eyeball. And the arms and legs are actually getting longer. You can tell that those are arms and legs now. All that soft tissue around the bottom, that's the developing placenta. And at this point, the placenta is going to be larger than the baby itself. Here we see a close-up of the developing hands of a baby who's 10 weeks from its last menstrual period. Now here I'm changing up the dating system on you a bit. Many women know the date that they conceived, or they have an idea of when they got pregnant, and they count usually the number of weeks from that time. But when they go to see a doctor or midwife for the first time, their pregnancy is dated from the first date of their last menstrual period, essentially adding 2 weeks to their number of weeks of gestation. So this 10-week baby from last menstrual period is the same age as a baby who's 8 weeks from conception. Notice how those flat discs that were the baby's hands are now starting to form fingers. Notice also the enlarged areas at the end of the fingertips. We see that type of development in areas that have a lot of nerve endings. The fingertips, the lips, the cheeks, those areas develop first. We can also see that the baby's mouth is forming, and even that little dip in the upper lip is beginning to take shape. Here we see a baby at 12 weeks of gestation. This baby is surrounded by a cloud of placental tissue. And again, you can see how much brain development is occurring. At this point, the head is much larger than the rest of the baby's body. Here's a baby's hand at 12 weeks. Notice blood vessels are forming, as well as fingernails and fingerprints. The baby's unique identifiers are already forming on its fingerprints. And here's a baby a little bit over 3 months of age. This baby also did not survive. What we can see from this baby is how long the limbs become and how thin they are until they get strong enough to develop a lot of muscles. We can see that the baby's head is the largest part of its body, but how long the fingers have become and the formation of the bones that's beginning to develop. At 3 months, the baby's ear is starting to form. We can see that that's an ear, but we can also see that it's not quite finished. The cartilage structure of the ear isn't fully developed. and the lobe hasn't separated yet. We'll see an ear developed a few more months later and see how much change has occurred. Here we see a baby at 15 weeks. From 8 weeks until birth, the baby's termed a fetus, but again, most moms are going to call it a baby. We can see that this baby has fused eyelids over its eyes now, has long fingers and fingernails, a fully formed nose and lips, nipple buds, and long arms and legs. This baby is moving about a lot, but the mother may not be able to feel it depending on how sensitive her stomach is and how strong her baby is. Here's another baby at 15 weeks. Look at how long that umbilical cord is. It connects from the baby's navel back to behind it where the placenta is, been fully functioning for a number of weeks now. We can see the developing ear and eyelids, and again, the length of the arms and legs. Pay close attention, though, to the size of the head in relationship to the rest of the body. It's largest, even larger than its torso in developing abdomen. Here we have a foot at 16 weeks. Again, we see a lot of the circulatory system developing, the toenails forming, and again, the baby has unique footprints already at this point. By 18 weeks, babies are able to move around and extend their limbs quite a bit. This baby is able to get its thumb into its mouth and suck. Now imagine what that feels like to this baby. It's able to feel the rough texture of its tongue on its thumb. It's able to feel the pressure of sucking on the thumb finger. It's able to feel the boniness of its finger in its mouth. It can also probably push out against the wall of the uterus, feel its sponginess. So babies have a lot of sensory experiences in the womb long before they're born. Here we see a baby girl at 18 weeks. And usually around 18 weeks, the external genitalia has differentiated enough for boys and girls that its gender can be determined. It looks like this baby is running out of room, but in fact, the uterus grows at the rate that the baby grows. So this baby is always going to look cramped in there. We can see light from the outside filtering through the wall of the uterus, and the baby can see that as well. Now, right now, her eyelids are still fused, so she can't see much. But as her eyelids develop and open, and she can blink, her pupils will be able to dilate in response to light shining through. Also notice the long umbilical cord that's wrapped around under her legs. Don't worry about that cord. The magic structure of the cord prevents it from getting kinked and knotted so that the blood flow can continue through it. And here's that ear I was talking about. Look now how the lobe stands out from the ear and how much more cartilage has developed. And you can see that that ear connects into the inside just like it's supposed to. Here we have a baby at 5 months of age. This baby is growing hair. It's got soft, downy hair all over the surface of its body. That's going to help hold lanugo, which is a creamy substance in place that protects the baby's skin when it's in that watery world the whole time. Notice that the baby has very well-developed facial features, fingernails, arms and legs. And here we see that vernix I was referring to, all clumped up in this baby's eyebrows. This baby is also demonstrating a good reflex called the Moro reflex, which is a startle response. Brings its arms and hands up in front of its face and protects its face and torso. This baby is 24 weeks, and this is usually considered the earliest age that a baby could survive if it was born. It would need a lot of medical attention to help it adjust to life outside the womb, but could survive. And here we see a baby at 7 months. Notice the curved nature of the umbilical cord, how it's spiraled like that. That's another way to protect the cord and the important blood vessels inside from being compressed or kinked. Notice the girth of the upper chest and how narrow the pelvis is. This is really normal. Babies aren't exercising the lower part of their body to develop big muscles. And they're not having to support the weight of their body, so the pelvis doesn't grow big until after they're born. You can see that this baby has nicely defined leg muscles, and I'm sure that it's giving its mother quite a workout with its kicks. And here we see a little boy at 36 weeks. You can see the placenta taking up a large portion of the uterus down in the lower right-hand corner. You can see the scrotum and the penis, defining that this is indeed a little boy. And this little guy is getting kind of squished in there, so he's running out of room. This baby will probably be born in the next number of weeks. And here we see a full-term baby at 39 weeks after the finishing touches have been put on. Notice those nice folds of fat on her arms and legs. This tells us that she's put on a layer of fat under her skin that's going to help regulate her body temperature. She's got a nice full head of hair, as well as some sideburns and shoulder hair too, much to her parents' delight. This is really common with new babies, to be born with extra hair that will fall out. Also notice that she's got a darkened area over her buttocks. That's called Mongolian spots, and is very common in babies who have dark skin heritage in their family. Those Mongolian spots are pigmentations and will usually stay in the same size. They don't grow with the baby, and they may even fade over time. Those bands on her legs, she got those after she was born.